let's look at a number system that we care about in computing. This is base 16, and since we use it in computing, it's gotten a special name or a name that we use often. This is hexadecimal, often referred to as just hex. So let's look at our digits. Now this is a base 16 system, but let's go with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But now I have a problem because this is base 16. I need to have symbols for everything up to 15. So I only have symbols up to 9 here. So what I do generally, and this is a convention, is I'm going to use capital letters. So after 9 is going to be A, that's going to represent 10. B represents 11. C represents 12. D represents 13. E represents 14. And F represents 15. Now I have my 16 digits with 0. I need to write all of my numbers. Okay, place values. I'm going to start on the right with 1, and then 16, and then 16 squared, and then 16 cubed, and then 16 to the 4th, and so on. Now this system grows, or its place values grow rather rapidly. 16 squared is 256. 16 cubed is 4,096. 16 to the 4th is 65,536. Okay, so a 5-digit hexadecimal number is at least 65,000. And let's do some quick counting. Now remember, whenever I write a number with a different base than 10, I put either I put a subscript on it that is either the number of the base or the word that's a number of the base. There's 1. I represent that as 1 base 16, of course. 2 is 2 base 16. 3 is 3 base 16. 4 is 4 base 16. 5 is 5 base 16. 6 is 6 base 16. 7 is 7 base 16. 8 is 8 base 16. 9 is 9 base 16. 10 is A base 16. Remember, I don't need 2 digits to write 10 in base 16 because I have a single digit for it. 11 is B base 16. 12 is C base 16. 13 is D base 16. 14 is E base 16. 15 is F base 16. And now I'm up to 16, and I'm out of digits, so I need to go to the next one. I have 1 16 and 0 more, so 1 0 base 16 is the number 16. Here's the number 17. It's 1 1 base 16. The number 18 is 1 2 base 16. The number 19 is 1 3 base 16, because that's 1 16 and 3 more. There's the number 20. It's 1 4 base 16. The number 21 is 1 5 base 16, and so on. Okay, all the way up to do I want to do another example or get counting here? Sure. If I'm at 9 9 base 16, I want to know what the next number is. I have to remember that it is 9A base 16. Right? Because I can go up one more in this digit. I can go up to an A. So the 9B base 16, 9C base 16, 9D base 16, 9E base 16, 9F base 16, and then my next number is going to be A0 base 16, right? Because I can go up one more in this digit, so I go up to A, and so on. Be careful when counting in hexadecimal. I think it's one of the hardest ones to count in, just because our minds see a 9, try to go up one more, and we're like, we want to just change the digit to the right when we don't in base 16. The number after 9 is an A in base 16.